Hey, Algebra 2, today we are going to take notes on graphing polynomial functions for the second day. So open your packet. This note sheet is in your packet and you can follow along with me. The first thing we want to do is take a look at the degree of our polynomial. When it's in factored form, we just need to count the x's. There are 1, 2, 3, 4, so the degree would be 4. Which we know that makes it a quartic. So in our mind, let's start thinking about the end behavior sketch. Okay, the leading coefficient, there's no number out front, is positive. So we know the end behavior should be doing something like this. Both sides pointing up towards positive infinity. Now, in order to get a sketch of that, we need to find our zeros. So to find our zeros, we take our function and set it equal to 0. And we have x minus 1, x plus 3, x plus 1, and x minus 2, set equal to 0. These quantities are all mental math, so what makes this 0 are x equals 1, negative 3, negative 1, and 2. So over here are real zeros, 1, negative 3, negative 1, and 2. Well, we know that another name for zeros is x-intercepts. So these real zeros are where the function crosses the x-axis. So negative 1, positive 1, and negative 3, and positive 2. Okay, so we need just a little bit more information to graph the function. If there are 4 real zeros for our degree 4, how many imaginary zeros are there? There are none. Okay, let's not put 0 there because that would make us think it might be a coordinate. Now, how do we find the y-intercept? Remember, the y-intercept has a coordinate of 0, comma something. So if I want to find the y-intercept, okay, I'm going to plug in x equals 0. So I would have y equals 0 minus 1, 0 plus 3, 0 plus 1, 0 minus 2, which gives me negative 1 times 3 times 1 times negative 2, which gives me a y-intercept of positive 6. So 0, 6. Other than that, I don't know too much more about the graph. I know that on the right and the left, it has to, go back. It has to point towards positive infinity. So I'm going to be cutting through on the right and the left, something like that. And then I'm going to have some turning points that'll look a little bit like that. Now your sketch might be a little bit different depending on where your turning points are, but in general they should look similar in terms of the main properties. So let's try again. Alright, so I take a look at my function and first I want to find the degree. Notice that x is squared, so this counts as 2. This is 1, 2, 3, 4. Again, a quartic function. Okay. If I think about my end behavior and my sketch for a quartic, that means my end behavior is pointing in the same direction. This time, they're both pointing down because of that negative leading coefficient. So let's find our zeros. We take each of those quantities and set them equal to 0. If I wrote out x minus 2 times x minus 2, remember that would give us the same 1. And what we've learned is that when that quantity is squared, that this causes a bounce. So we know here we're going to get a bounce. Touches the x-axis and goes right back down or right back up. So set this equal to 0. I get x minus 2. And again, my zeros are mental math. I'm going to have zeros at x equals 2, 1, and negative 1. Again, this is going to be a bounce. That's important. So when I put those on there, 2, 1, and negative 1. I know that I should not cut through at 2. I should touch 2, and since it's on this side, go right back down. Okay, so I have 4 real zeros, okay, which are actually, let me take that off there. Let's put what they are. My zeros are 2, 2, 1, and negative 1. Again, we're counting 2 twice. There are no imaginary zeros, and again, to find that y-intercept, we plug in 0 for x. So y equals negative 0 minus 2 squared, 0 plus 1, 0 minus 1. So when I do 0 minus 2, that's negative 2. Negative 2 times negative 2 is 4. And with this negative out front, so I've got negative 4. This gives me 1 and negative 1. So I have a y-intercept at positive 4. So when I go to draw my sketch, it's really important that, again, I focus on that bounce. I touch it, I come right back down the same direction. On this side right here, I'm coming from underneath my from my end behavior. I'm going to come up and touch this turning point. I'm going to have a quick turning point. When I touch 2, I'm going right back down. Again, this is the bounce right here. And then I'm done. If you miss the bounce, if you don't pay attention to it, if you tried to cut through 2, then you would be stuck because you wouldn't have another place to come back down to match your end behavior. All right, let's keep going. Let's do it again. Okay. Notice the difference on, whoops, sorry about that. Okay, so notice the difference here on these quantities right here. Some people might ask, why isn't this a bounce? Okay, the difference is this squared is on the x, not on the quantity. So this squared right here does not cause a bounce, only when it's on the outside of the parentheses. So our degree here, though, we've got 2 x's, so x squared, 1, 2, 3. That makes this degree 3. We have a negative leading coefficient for an odd degree, so it's going to look something like this. Okay, let's go find our zeros. So when I take negative x squared plus 4 and x minus 1 and set it equal to 0. Well, this one I need to do x squared plus 4 equals 0. Subtract 4 from both sides. Square root it, and I get x equals plus or minus 2i. My other 0, x minus 1, equals 0 is just mental math. So I only have 1 real 0 at x equals 1. I have 2 imaginary zeros at plus or minus 2i. So this is all I get right here for my x-intercepts. Now what does it mean when I have imaginary zeros? That means that they don't touch the x-axis. Finish up by finding the y-intercept. I get y equals negative 0 squared plus 4 and 0 minus 1. Well, 0 squared is just 0, so I end up with negative 4 times negative 1, a y-intercept of 4. That's all I get. I know my end behavior has to come through here. Okay, I can take this and maybe do a little curve like that. But the only things I know for sure is that my end behavior on the left is pointing up, on the right is pointing down. I know that my function cuts through the x-axis at 1, there's no bounce there, and I know the y-intercept is 4. Other than that, that's the best sketch I could probably give right now. Let's try one more. Okay, so on this one, if you notice, the degree is easy to pick. It's in standard form. But the zeros require a little bit more work. We need to factor this before we can find those zeros. So when I see 4 terms, right away I think factoring by grouping. So I'm going to group the x cubed and the x squared. And I'm going to group the negative 4x minus 4 and set it equal to 0. Find the GCF in the first two. Oops, no square there, just plus 1. Take out negative 4. I get x plus 1. Continue grouping. I get, oops, x squared minus 4 times x plus 1. And that x squared minus 4 can be factored one more time. And so I get zeros at x equals 2, negative 2, and 1. So 2, negative 2, and 1. Oh, yeah, sorry. Okay. I have 3 real zeros. I have no imaginary zeros. Okay. I need to find the y-intercept. I plug in 0. I get 0 cubed plus 0 squared minus 4 times 0 minus 4 gives me a y-intercept at negative 4. So here's my y-intercept, my negative 2, positive 2, and 1. So last thing I want to think about is my end behavior. Okay, I've got an odd degree with a positive leading coefficient. Means it has to look something like this. So starting from the left, I'm going to start underneath. I'm going to cut through the x-axis. And hold on. Aha! See? I caught my own mistake. This should be negative 1. Otherwise it doesn't make sense, does it? Good catch for all of you that already caught me before that. So let's take this guy off here. Aha, because otherwise it wouldn't have made sense. There was nowhere for it to come down and get that y-intercept. So now we come down and go back up. And you should use good reasoning. If something's not making sense, like that wasn't making sense right there, if I would have gone up there and I had to get back down to that y-intercept, I knew something was wrong. So as soon as I did that, I glanced over there. Sure enough, there was my mistake. Alright guys, your homework is to do that second day 2 of graphing. See you on Monday. Thanks for working hard today.